What I'd like to do here is take a couple different polynomials, you can see them over on the left, and start zooming out. We know what polynomials do in the middle. They wiggle, and tomorrow we're going to be spending a lot more time on the little wiggling they do when you don't move too far away. What we want to do with this one is ask what happens when we zoom out. So I just graphed this in standard. I think I graphed this in standard. There's a little home button here. Yes, I did. And I would like to start zooming out and seeing if I can't be careful about how I'm zooming out so I can actually see the graph. So if I zoom out some, I get that. Zooming out again, I get that. Zooming out that, I get again. Now I'm losing all part of the picture. Let me just zoom out into a ridiculous amount. Now the reason I'm missing so much of the graph here is because I'm not making the y values on the window big enough to actually see the graph. So I'm going to go over to the wrench, and I see over here that the y values go from like minus 400. What I would like to do is I think I'm going to do something like 10,000, just so I can see what's going on. Like that. Okay, well, let's try a little bit more. Let's add another 0 over here, add another 0 over here. Close the wrench so we can actually look at the picture. And what does that look like? Well, from what we did yesterday with power functions, that looks like y equals x cubed. We zoomed out so much that we can't see the little wiggling. All we see actually is the x cubed. Now what does that have to do with our original formula? Look at our original formula. Our original formula starts out with x cubed, and all the stuff that causes the wiggling just sort of went away when we graphed and zoomed out. That is very typical of polynomials. Let's do this again. I'm going to shut this one off. I'm going to turn the second one on. I'll go back to home, right? And oh boy, this thing is doing an awful lot of wiggling. I can't see all the wiggling because I'm not going up and down high enough. So what I'm going to do is just go up and down instead of going from minus 6 to 6. How about if I go from minus 100 to 100? And I can almost see, I think, all of the wiggling. Now, how do I know it's all the wiggling? Well, this is the 6th degree polynomial. When I set that equal to 0, I should get 6 roots, and I'm thinking I'm counting 1, 2, 3, 4, 5, 6. So I have a good picture here of the whole thing, and that's a normal picture. But what we really want to do today is zoom out and see what happens to the polynomials when we zoom out. So what I want to do, I'm going to start zooming out like we did last time. So I go over here, I press the zoom out button, zoom out button, zoom out button, zoom out button. Now you can see, by the way, that I'm not using much of the positive part here at all. I'm just using the bottom part, but I'm getting so skinny that I can't see it. I would like to try the same thing I did last time. Let's just add a lot more negative values. A lot more negative values. Let's see here. Can I do this? I'm trying to get over here and it won't let me. Like this. Nope, still not over there. Let's say negative 100,000. That's not quite enough. About 100, a million, 10 million. Okay, I now have a picture I can see. Yeah, I'm going to add some to the positive part, so well, it won't let me see it. There we go, just a little bit. All right. So I zoomed out enough so I can see a good picture. I'm comfortable that it's not going to do any strange stuff out here. All the wiggling that we normally think about polynomials is all over here. Now, from yesterday, what does this graph look like? Well, that looks like a power function with an even power with a negative coefficient in front of it that got flipped down. So there should be x is some even power with a negative coefficient. Well, if I go over to my polynomial over here, this is what we're actually plotting. Just look at the leading term. What do we have? We have x to an even power and a negative coefficient. And again, we graphed a polynomial. We zoomed out until we saw none of the wiggling, and we got enough good picture to look at. And what we saw was basically a picture of the leading term. Okay, we're going to try this one more time. I'm going to go back to the home screen. And what we want to do is try to guess what this is going to look like ahead of time when we zoom out. Now I'm looking at this thing here. I see a 5th degree polynomial. You can have 5 roots and 4 wiggles, but we'll worry about that tomorrow. What I want to do is just look at the leading term. Now, what does an odd power graph look like? Remember that it looks like an S. It goes like this. Oops, don't want to do that. I'm following my cursor. It comes over to 0. It usually completely flattens out, and then it goes up like that. Now, this has a minus 10 in front of it, which should have flipped it upside down. So following the cursor again, I go way up here like this. It should come down like this. It should get very flat at 0, and then it should go down. Now we're going to check to see if that's right. I'm going to graph it, and again, I can't see much of a picture because it's too high. We can zoom out, I guess, if we want to, but I'm missing so much of the graph because nothing is happening with the x's, and the y's are increasing too fast. So I'm going to do what we did before. I'm going to try to come over here, and I'm going to make this, say, 10,000. And I'll make this one 10,000, and just see if I can't see a bit of the picture. Okay, we're going to start with that. I'm going to zoom that in a little bit to see if I can just see some of the wiggles. So this is sort of what I think what the graph would look like. I think it has 2 complex roots and 3 real roots, but it doesn't seem to be doing any more wiggling. But today it is not about the wiggling. Today is about zooming out and seeing what the graph looks like. I know what we said it was going to look like. Let's just zoom out a couple times and see if it really looks like that. It kind of does. I want to check the window a little bit to see if I can't make this do what I want to. Let's see. I'm making the negative 100,000 and the positive 100,000, like that. Yeah. Let's see here. Does that look like what I want it to look like? I think it does. Let's see, if I have the x's, instead of going to negative 300, let's just have the x's go from like negative 50. Just trying to have a good zoom out window so I can draw a conclusion. Let's make that 50, like there. There we go. Now what did we say it was going to look like? We said it was going to come down like this. It was going to completely flatten out, and then it was going to come down. Sure enough, if we wanted to know what it looked like after we zoomed out, all we had to do was look at that leading term. In the next little video, we'll talk about how algebraically we'll discuss why you only have to look at the leading term in order to see what's going on way to the left and way to the right.